Mr. G, again, if it's a function, do I have a choice? Yeah, you do whatever is easiest. But we're trying, you know on the exam, you're going to get hit with the implicit differentiation case, which will be today's activity. Let's do number 2. F of x is still a function, x squared minus 6 ln x. Find the x and y coordinates of all extrema. Okay? Alec, can you help me with the derivative, please?
2x minus 6 over x.
6 over x is good. Okay? Right away, you see that the derivative is undefined at 0. So we already know f prime of x is undefined at x equals 0. Also set the derivative equal to 0 to see if you get another value that is a candidate. Mr. G, the derivative is undefined at 0, but look, 0 is not part of the domain. You can't have natural log of 0. You can scratch that off right now. We consider it and we tossed it. It's garbage. Okay? Now we set it equal to 0, multiply by x squared. Add 6, divide by 2, find cubic root. Who would like to tell us what's, yeah, we do something wrong?
Only x, not x squared.
Oh yeah, bad things are happening. Thanks a lot, Nick. Multiply by x. Is that better now, class? 2x squared. So it's x squared equals 3. Class, is that better now? And x equals plus or minus root 3, but I only want positive root 3. Who can tell me why I only want positive root 3? Katie.
You can't have the natural log of a negative number.
Well said. No negative natural logs. So the only critical value you need to consider is root 3. All right, now you got a decision to make. Do you want to use the number line? Should be okay. But do I want to do the second derivative? I'm going to stick with the first derivative test. It's only one value. Okay? 0 is my boundary. So I need to check these two things. Okay? First derivative test, that's about 1.73. Let's do 1. In my first derivative, 1, 2 minus 6 is negative. 2. 4 divided by minus 3 is positive. So we have a relative min at root 3, f of root 3. Class, I hope you saw that I decided, and the first one was pretty easy to go to a second derivative. And this one, I only have one value. I stuck with the first derivative. Okay? How about if I give you one for you to do on your own? Number 3. Is there a question for G so far? Kind of learning something? Good. How about f of x equals 2? X plus x to the 2/3. That should look pretty familiar from the do now and from the homework. Find all relative extrema. Mr. G, the second derivative may be pretty easy. Because look, the first derivative, this is 1. And what happens to that term when we find the next derivative? It is 0. So you're just dealing with one thing. Do it any way you want. Okay? who did the first derivative test and got the same results? Olivia, bring it up so we can show it. Jump. There you go. Good job. Before we go to the first derivative test, who can tell me why the second derivative test was easier once you got the second derivative? It has to do with computation. How come I didn't do much? I was able to do this in my head. Connor.
The second derivative is always negative.
It was negative because this is always positive.
Yeah.
So positive times negative is going to be negative. It's going to be negative except at x equals 0 where it's undefined. And that's what we got. 0 and some other random number. Okay? Who's got a question about the second derivative test? No.
If you do the second derivative test, will it automatically rule out the 0 or undefined something?
Say that again.
If you do the second derivative test, will you automatically rule out all the zeros or undefined from the test?
I still don't get the question. One more time.
If you do the second derivative test, like here, where you didn't get the 0 and the 0 was undefined, does it always happen like that, or do you always get the 0?
I don't know what he's trying to ask you. Somebody paraphrase it a different way about the 0. I want to give you an answer. I think you're trying to say, I'm trying to ask if it always works that way. And I don't want to commit myself to that. All right, Jack.
I just have a,
Okay, hold that thought for just a second.
it's,
Yeah, it's fine.
It's fine, it's good? Okay, okay, go ahead, Jack.
so if you plug in any, so if you find out that the second derivative is either positive or negative, that's how you just decide, like.
Right, but it doesn't always work that way. In other words, in this case, what's nice about it is you can tell right away that it's always positive or negative. It's not always going to work that way.
And if it doesn't,
Then you just plug in the number. Let's say you get a second derivative that's, x squared minus 2x plus 3. Then you just plug it in and see if it's positive or negative. You don't need the exact value.
Plug in that, I can plug in.
The
that
critical value of the first derivative. That's right. Somebody else with a question or comment. Okay, let's show the first derivative test. So this is okay. I think negative 8 over 27 is negative 0.296, right?
Yeah.
And but I think there's something wrong here because according to this, there's a relative min at 0 and a relative max at this point. So I think one of these is wrong. Okay, so let's see. 1 plus 2/3 x to the 1/3. If I plug in 1, I get positive. If I plug in negative 0.1, all right, or something in that interval, can somebody do it out for us, please? If you plug in negative, do the 2 divided by 3 times negative 0.1 to the 1/3 power, and then add 1.
It's positive.
It's positive, and I think this guy is negative here. If you do the cubic root of some number. So we have a relative. I think we screwed this up. Let's do it again. Okay, here's her first derivative, 1 plus x 2/3 x to the 1/3. If I plug in 1, it's positive. Okay? Mahek, you said this was positive?
Alright, I did it again, it's negative.
It's negative?
Yeah, parentheses.
Maybe she had him right. What did we do wrong? This is not matching. Not matching with the previous answer. Negative 1. If I plug in negative 1 here, I get negative 1. This is positive here. What are we doing wrong? Adjust.
When I did the derivative of, or when I did f double prime of x. I
But
got-
we're not doing f double prime. We're just doing f prime.
Oh,
What is it?
Wasn't there a relative max at that point?
Yeah, I know. So we've got issues, okay? right, let's take a look, see where we made our mistake. Somewhere we've got a mistake.
That's what you have.
You have a row.
You have it.
I have it?
Like on her paper, it goes from positive to negative. like that.
Okay, so she's got positive and negative, so around the max, but I don't like the zero. Zero's wrong. Because it's zero, f double prime is nothing. So what's the, we got a mystery here.
Mr. G,
Yes,
with the first derivative, if you plug in 0, you get 1 plus undefined.
yeah, but it's still undefined.
Okay.
So why doesn't 0 work?
Zero's a point on the original graph, right? Issues. All right, look at the second derivative test. The second derivative test, x equals 0, the second derivative, the first derivative is undefined. We plugged it in here, but we're not going to get anything. So therefore, there's no conclusion. But according to this, we have a relative max. The first derivative test tells us it's a relative max. Okay, I got you. She's right. The second derivative test was not conclusive. All right, I've got it. Wow. It must be Saturday morning. All right, class. Let's change the word neither here, okay? No conclusion is possible. We cannot conclude it using the second derivative test. That's, I didn't put the correct answer, okay? So it's inconclusive. Since it is a function, you can do the first derivative test and get the fact that there is a relative min at x equals 0 and 0. Okay, so Olivia did do it correctly. Okay, both values were correct. So in this case, the second derivative test is not conclusive for 0. You would have to do the first derivative test to get an answer. Katie, was that your question? Okay, so moral of the story, when it's a function and it's something where you're going to get two values, stick with the first derivative test. Good call, Olivia. Okay. All right. Let's do one more. Number 4. Wes, question for G. That's okay. Let me just go back to our notes for just a second. In our notes, oh, I did have it right in our notes. You see that? Our notes were right. No conclusion is possible. There's no way to tell. It might be. It could be around the maximum. It's not that there isn't one. You just cannot tell using the second derivative test. All right, so let's do this, and let's do f prime of x. And what we're going to do with this problem is we're going to find also the coordinates of the inflection points, okay? So here we go. 2x minus 2 to the 1 times x plus 1 squared plus x minus 2 squared times 2x plus 1 to the 1 times 1. That is going to give us the first derivative. Let's clean it up a little bit. Let's take out an x minus 2 and an x plus 1. And open up parentheses here.
Can you
This-
take out 2?
Yeah, you can take out a 2, good call. So I'm missing a factor of x plus 1 here. And for this guy, I'm missing a factor of x minus 2. So when we clean it up, we're going to get 2x minus 1. Okay? So the key is to getting that 2x minus 1 because you're going to pick up the 1/2. Okay? There. So I'm feeling the first derivative test. Who can give me a good reason why the first derivative test is even better here? We know it's a function. Well, what's the other giveaway? Wes. It's linear, so you know it's going to be a bunch of sign changes. So we've got a half, -1, and +2. Oh my God, I got the numbers in order on the number line, okay? So now if I find one of them, like say 3 would be good, positive, 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 I'm pretty certain that that's going to be the case here. Okay, so we've got a relative min, a relative max, a relative min at those values. Mr. G, I can find the y values pretty easy by plugging them back in. Let's skip that. That's not the point. Okay? And the last thing we want to show today is how to find the points of inflection. Well, you have no choice. For the points of inflection, you have to do the second derivative test. There is no way around it. And even if you're not using the second derivative test for the extrema, who thinks they know what do we have to do in order to be able to do product rule efficiently? I've got a lot of stuff there. What do you think, Grace? FOIL what? She's on the right track, but what do you think, Matt?
Or just FOIL like x minus 2 and x plus 1.
Yeah, you want to FOIL a couple of them, right? So you have two terms and a constant. Okay, so manipulate it a little bit. So f prime, right now it's 2 times, that's x squared minus x minus 2, and the other guy is 2x minus 1. And now we're in a better place to do product rule, okay? F double prime, leave out the 2, take out the 2 as a constant, 2x minus 1 times the 2x minus 1. Oh, delicious. Plus this times the derivative, which is 2. I'll put the 2 first, and the x squared minus x minus 2 second. And now I feel like doing this out because that's going to work for me. There's no GCF. 4x squared minus 4x plus 1 plus 2x squared minus 2x plus 2. 2 times. Did we screw up somewhere? Plus 4 minus 4.
Yeah.
Good call. Okay? So now we have 6x squared minus 6x minus 3 and take out a 3. So this is going to become 6. Take out a 3 out of each of those. 2x squared minus 2x minus 1. That does not smell factorable to me. I'm going to try it. No way. All right, so we want to find out where the inflection points are. Okay? And you know what's a parabola. So you know at those x values where the parabola is 0, it's going to be an inflection point, but it's because the parabola is going to go from being above to below or vice versa. So I'm hoping you're using your solver to do that. Yes, sir.
I got 1.366.
Somebody verify that. Okay. How about the other one? Jack.
Negative 0.367.
Somebody verify that, please. Yes? Okay. 367? 366? Okay. Good. Yes, Jack.
How did you get that square, the 2x minus 1, how come it's squared up at the top for the second derivative?
Okay, so the derivative of this dude is 2x minus 1 times the other guy, which is also happens to be 2x minus 1.
Gotcha.
That's how I got 2x minus 1 squared.
Gotcha.
Somebody else with a question or comment for G. Wes, all set? Brendan. Good? Beautiful. Okay, let's do part 2 of today's class, which is just a... Yes?
Do you want us to quickly move this instead of the wireless mic? It'll work better.
Yes. Okay, we'll stop for just a moment. Let me take a card. Okay, we're going to do the problem solving and the activity part of the lesson today, okay? So, part 2 of today's class, let's just do a problem to show how you can apply the second derivative test in a problem solving situation. Find k so that f of x equals x to the 4th minus k over x squared has an inflection point at x equals to -1? That is an excellent AP exam question. Obviously, they will tell you that k is a constant, not a variable. Okay? So it's related to what we're doing, all right? So let's see. I know the inflection point is at -1. So you got to work the problem backwards. What do you think you should do first in this problem in order to start breaking down the problem? What would be a good idea to do? Matt. And after you find the derivative, what would be a good idea? No, I don't think the number line is going to help us with anything. AJ. Yeah. Okay, AJ, go for the first derivative. I think, yeah, plus. I think you forgot the 2. Okay, so you bring up the x to the -2, -2 times -a is 2k, x to the -3, there it is. Okay, and Jack, can you help us with f double prime?
12x squared minus 6k over x.
All right, so we have the second derivative in terms of x, and now think, I know it has an inflection point at x equals -1. I know what I know what x is. What's f double prime at an inflection point? That's the concept we're looking for. It's 0 or undefined, but it can't be undefined. Well, your only choice is to plug in 0. And the rest is cake at x equals to -1. And actually, it's pretty easy if you think about it. The computation is going to be cake. Who can tell us what the value of k is? Demers. Class, can that be verified? Okay, great. That problem looks pretty hard on first glance. Jack.
What would you do if the second derivative was undefined?
Well, they make the problem so that they take that off the table. Okay, so they will say on the problem, here's how they take that off by saying for this function works only for x greater than 0, so that the x equals 0 undefined, it's taken off. They do that very consistently, so there's no confusion. Good call. Yeah, okay, that's the thinking part of the problem. The problem tells you there's an inflection point at x equals -1, so you're working it backwards. If I have an inflection point at x equals -1, that means the second derivative is 0 or undefined, so we plug in 0. Undefined, I took it off the table by making the problem, the function only for x greater than 0. Jess. Because I screwed up. Okay, so leave that out right now. How about if we make that for x not equal to 0, and now it works. Jess, that is a gold star comment. That was excellent, because we've been emphasizing how important domain is, and now she called me out when I try to fix the problem. I didn't fix it correctly. I should have done x not equal to 0, because it is x squared, so x could be negative, and that works. Good call. Nick, you too can get a gold star someday, okay? Yeah, I know so. All right. Okay. Okay, ladies and gentlemen, for the final part of the class is the activity part of the class, okay? So here are the things that you're going to do for today. First of all, you're going to do a worksheet, which is the regular homework, and I have an answer key for you. When you're done, show it to me, and I'll give you credit. We are going to eliminate finding the y value, which is kind of tedious, so that this goes quicker. Just find the x values where you have extrema. And we're going to eliminate the inflection points for today. Skip, you're going to have it in the G key. You know how to do that already, okay? So the homework goes a little quicker. You can work in groups with this, okay? Actually, that's number 2 for today. Number 1 is the activity, which is another handout. work collaboratively on that. There's two things. The first problem must use the second derivative test because it's implicit differentiation. When these two things are done, number 3, there's a bonus quiz, open notes individually. And this will go feed any low quiz grades for the past week. That's it for the rest of the day. There's nothing due on Monday. Are there any questions about what the 3 things are that you need to know? Yes. We will have a quiz on Monday over the homework we went over today. Yes, we will be. Okay? But there's no written work. We're going to get it done right here, and it's been modified. Jess?
Will there be a quiz on Tuesday on this stuff?
Quiz on Tuesday, if we go, yes, there will be, because we are doing the homework today. Good call. Yes? Yes. The paper you already have, which will look something like this, is the activity. This is the activity. Okay? The second problem of the activity is pretty fluffy. Okay? And the first one is the key activity for today, then the homework. All right? You can work with anybody you want. You can move the chairs. Alec, we're done with filming for today. Thank you very much.